Imagine a wolf. Now make it bigger, much bigger. Picture a creature with the power and presence to dominate its environment. This wasn't fantasy, but reality in the age of ice. A time when the world was a frozen wilderness, teeming with life adapted to the harsh conditions. The dire wolf, a predator of immense size and power, roamed Pleistocene North America. It was a formidable hunter, a true apex predator of its time. These weren't just oversized wolves, they were a distinct species, known scientifically as Aenocyon dirus. Their skeletal structure was robust, built for strength and endurance. Unlike modern wolves, they had larger, more powerful jaws, capable of crushing bone. Their fossils, discovered in places like the Brea Tar Pits, whispered tales of a forgotten era. These sites are treasure troves of information, providing a window into the past. These weren't just bones, they were puzzles waiting to be solved. Each fossil found adds a piece to the complex puzzle of their existence. Each tooth, each skull fragment, held secrets. They tell us about the diet, health, and even the social structure of these ancient predators. Scientists, like detectives at a prehistoric crime scene, pieced together the story of these vanished giants. Through meticulous research, they reconstruct the lives of these incredible creatures. They painted a picture of apex predators, hunting large prey in a world much different from our own. Their prey included mammoths, bison, and other large herbivores that roamed the icy plains. The dire wolf's extinction, along with other megafauna, marked a turning point in Earth's history. It was a period of significant change, reshaping the ecosystems of the planet. The why remains a mystery, a puzzle with missing pieces. Climate change, human activity, and competition with other species are all possible factors. But what if we could bring back more than just their bones? Advances in genetic technology are opening up possibilities once thought to be science fiction. What if we could revive the dire wolf itself? Imagine seeing this majestic creature walk the Earth once more, a living link to our planet's distant past. The key to resurrection lies in the language of life, DNA. But could such fragile molecules survive for millennia? The answer surprisingly is yes. Under the right conditions, DNA fragments can remain trapped within teeth and bones, like whispers from the past. Extracting this ancient DNA is a delicate process. It's like finding a needle in a haystack, then trying to reassemble the haystack from the needle. Scientists use specialized techniques to isolate and amplify these fragmented strands. Each fragment, a tiny piece of a much larger puzzle. By comparing these fragments to the DNA of modern-day wolves, scientists can begin to reconstruct the dire wolf's genome. It's a painstaking process, but the reward is a glimpse into the genetic makeup of a long-extinct species. Imagine a library where the books are scattered, pages torn, and languages long forgotten. That's the challenge of reconstructing an extinct genome. But instead of books, we have DNA fragments. Each fragment holds a small part of the dire wolf's genetic code. Scientists use powerful computers and sophisticated algorithms to piece together these fragments. They compare them to the genomes of living relatives, like wolves and dogs, to fill in the gaps. It's a process of trial and error, requiring immense computational power and human ingenuity. The result? A digital blueprint of the dire wolf. This digital blueprint isn't just an academic exercise, it's the key to bringing back the dire wolf from extinction. With the dire wolf's genome mapped, scientists have taken the first crucial step in the journey to bring this magnificent creature back to life. The next challenge is to bring it to life, a task that requires cutting-edge technology and a deep understanding of genetics. This is where the science of cloning comes in, a field that has evolved tremendously over the past few decades. Cloning isn't science fiction, it's a reality that has already been achieved with several species. Scientists have already cloned numerous species, demonstrating the feasibility of this complex process. From sheep to monkeys, the success stories are numerous and inspiring. The process involves replacing the DNA of a donor egg cell with the DNA of the extinct animal, a delicate and precise procedure. In this case, the DNA of a closely related species, like a gray wolf, would be used as a starting point to ensure compatibility. The gray wolf's DNA provides a suitable template, making it an ideal candidate for this groundbreaking experiment. The dire wolf DNA would then be carefully inserted into the egg cell, a process that requires extreme precision and expertise. This effectively transforms the egg cell into a dire wolf embryo, marking the beginning of a new life. This embryo would then be implanted into a surrogate mother, likely a gray wolf, to nurture and bring it to term. If all goes well, the surrogate would give birth to a healthy dire wolf pup, a remarkable achievement in the field of genetic science. This would be a testament to the power of science and human ingenuity, offering a second chance for a long-lost species. The successful birth of a dire wolf pup would not only be a scientific milestone, but also a symbol of hope for the future of conservation and biodiversity. Section 5. A New Dawn, an old predator, introducing the dire wolf into the modern world. Bringing back the dire wolf isn't just about recreating the past, it's about shaping the future. These majestic predators could play a vital role in restoring balance to ecosystems disrupted by human activity. Imagine them roaming vast wilderness reserves, their presence keeping herbivore populations in check. Their reintroduction wouldn't be without challenges. We need to carefully consider their impact on existing species and ecosystems. Where would they live? What would they eat? How would they interact with humans and other predators? These are complex questions that require careful study and planning, but the potential benefits are enormous. The dire wolf could become a flagship species for conservation efforts, a symbol of our commitment to restoring the planet. Section 6. A Balancing Act. The ecological impact of de-extinction. The concept of de-extinction, or bringing back species that have long been extinct, is both fascinating and controversial. It raises numerous questions about the ecological balance and the potential consequences of reintroducing these species into modern ecosystems. The reintroduction of any apex predator, especially one long gone, is a delicate dance. Apex predators play a crucial role in maintaining the health of ecosystems by controlling the populations of other species. However, reintroducing a species that has been absent for thousands of years adds layers of complexity. The dire wolf, with its size and predatory prowess, could significantly alter the ecological landscape. Its presence could reshape the food web, affecting not just its prey, but also other predators and even plant life. The ripple effects of such a reintroduction are vast and unpredictable. Would it compete with existing predators like wolves and bears? The introduction of a new apex predator could lead to intense competition for resources, potentially displacing or even endangering current species. This competition could have far-reaching consequences for the entire ecosystem. Would it help control populations of overgrazing herbivores? Overgrazing by herbivores can lead to habitat degradation, affecting plant diversity and soil health. A new predator could help keep these herbivore populations in check, promoting a more balanced and healthy ecosystem. Scientists are using complex models to predict the potential impact of dire wolves on various ecosystems. These models take into account numerous variables including prey availability, habitat suitability, and interactions with other species. The goal is to anticipate and mitigate any negative impacts. They're studying the behavior of modern-day wolves, analyzing prey availability, and mapping suitable habitats. By understanding the needs and behaviors of existing predators, scientists hope to make informed decisions about where and how to reintroduce the dire wolf. The goal is to ensure that the dire wolf's reintroduction doesn't create more problems than it solves. This involves extensive planning, collaboration among ecologists, and ongoing monitoring to adapt to any unforeseen challenges. It's a balancing act, weighing the potential benefits against the risks. The reintroduction of a species like the dire wolf could bring about significant ecological benefits, but it also carries the risk of unintended consequences. But with careful planning and ongoing monitoring, the dire wolf's return could usher in a new era of ecological restoration. If successful, it could serve as a model for future de-extinction projects, demonstrating how we can restore balance to ecosystems and bring back lost biodiversity. Section 7. Voices of Caution and Optimism, Ethical Considerations of De-Extinction. The prospect of bringing back extinct creatures raises profound ethical questions. Some argue that it's hubris, tampering with the natural order. Others worry about the welfare of these resurrected animals. Would they thrive in a world vastly different from the one they evolved in? Conversely, proponents of de-extinction argue that we have a moral obligation to right the wrongs of the past. Human activity drove these creatures to extinction. Shouldn't we try to bring them back? They also highlight the potential ecological benefits, arguing that de-extinction could help restore damaged ecosystems. The debate is complex, with valid arguments on both sides. It's a conversation that requires careful consideration of our values, our responsibilities, and the potential consequences of our actions. Section 8. A new era of discovery, the future of de-extinction. The successful revival of the dire wolf could usher in a new era of de-extinction. Scientists are already eyeing other extinct candidates, from the majestic woolly mammoth to the iconic passenger pigeon. Each species presents its own unique challenges and opportunities. Imagine a future where Pleistocene parks dot the globe, where herds of mammoths graze alongside resurrected aurochs. Imagine the skies filled with flocks of passenger pigeons, their numbers once again darkening the sun. This isn't just science fiction, it's a potential future, made possible by advances in genetics and our growing understanding of ancient life. Section 9. Beyond the dire wolf. A world reborn. The de-extinction movement is about more than just bringing back lost species. It's about reimagining our relationship with the natural world. It's about acknowledging the damage we've done and taking responsibility for restoring what we've lost. It's about recognizing that we are not separate from nature but a part of it. The dire wolf, once a symbol of extinction, could become an emblem of hope, a testament to our ability to reverse course and create a future where both humanity and nature can thrive. It's a future worth striving for, a future where the echoes of the past inspire us to create a better tomorrow.